The National Electrical Code (NEC) addresses the length of a metered conductor or riser cable allowed inside a dwelling before the meter. NEC Section 230.71 covers meter locations outside of buildings. Specifically, subsection F states that for service conductors connected to an overhead service entrance, the connection point should be no less than 9 feet and no more than 20 feet above the finish grade. If the service conductors connect to a service lateral, the connection point must be at least 30 inches from the grade. If the overhead service conductors are more than 20 feet above the finish grade, according to subsection B, they must terminate on weatherproof terminals or a service head. Furthermore, according to subsection C, the service equipment must be installed in a readily accessible location either outside the building or inside nearest the point of entrance of the service conductors. The NEC addresses whether a riser cable can be installed in a pipe riser inside the dwelling wall and then go outside to the meter before it comes back inside to the panel. NEC Section 230.70 subsection A provides guidance. This section generally requires service entrance conductors and services to be installed according to the requirements outlined in the article unless the code specifically permits otherwise. It states that service entrance conductors should not be installed within a hollow space such as a partition, wall, or ceiling of a building unless specifically permitted elsewhere in the code. Service entrance conductors must terminate in approved service equipment, like a service panel or service disconnect. However, exception number 1 allows service entrance conductors within hollow spaces of buildings used strictly for dwelling purposes. However, it stipulates that they cannot be installed outside the hollow space of the building for more than 20 feet. The conductors must be installed in metal raceways, which must be grounded or be type MI cable. The service equipment must be located adjacent to the point of entrance of service entrance conductors into the building, inside the hollow space. Splices or taps are not permitted within a hollow space unless made and installed according to section 300.15 as applicable. Regarding who decides what is acceptable, whether the inspector or the utility, it is ultimately the electrical inspector's responsibility to determine if an electrical installation complies with the NEC. However, the utility company may have additional requirements that must also be met. The utility company may have specific requirements for the type of cable used, the installation method, and the location of the meter. It is important to check with the utility company before installing the riser cable to ensure it meets their requirements. The NEC establishes minimum safety standards, and local jurisdictions or utility companies might have more stringent requirements. The electrical inspector enforces the NEC and any local amendment. The utility company is concerned with the safe and reliable delivery of electricity. This means they may have specific requirements to protect their equipment and personnel and to prevent theft of service. The NEC provides the basic rules for electrical installations. It aims to safeguard persons and property from hazards arising from the use of electricity. Section 90.2 of the NEC outlines the scope of the code, clarifying what it covers and doesn't cover. The NEC covers electrical conductors and equipment installed within or on public and private buildings or other structures, including mobile homes, recreational vehicles, and floating buildings, yards, lots, parking lots, and industrial substations, installations of conductors that connect to the supply of electricity, installations of other outside conductors on the premises, installations of optical fiber cable, and generation, transmission, and distribution of electrical energy to supply buildings, structures, or contents. However, the NEC typically does not cover installations in ships, watercraft other than floating buildings, railway rolling stock, aircraft, or automotive vehicles, and installations under the exclusive control of an electric utility where such installations are located in buildings used exclusively by the utility. The NEC is not a design manual. It provides rules for safe installation, but it doesn't tell you how to design an electrical system. That is the responsibility of a qualified electrical engineer or designer. The NEC is updated every 3 years. This ensures that it reflects the latest technological advances and safety practices. The NEC is adopted by state and local jurisdictions. However, some jurisdictions may amend the NEC to reflect local conditions. Electrical inspectors are responsible for enforcing the NEC. They review electrical plans, inspect electrical installations, and issue permits. To become an electrical inspector, one typically needs to have experience as an electrician and pass an exam. There are different types of electrical inspections, including rough-in inspections, which are performed before the walls are closed up, and final inspections, which are performed after the electrical installation is complete. Electrical inspections help to ensure that electrical installations are safe and comply with the NEC. If an electrical installation fails an inspection, the inspector will issue a list of violations that must be corrected. Once the violations have been corrected, the inspector will re-inspect the installation. The NEC is a complex document. It's important to consult with a qualified electrician or electrical engineer if you have any questions about the code. The NEC is available for purchase from the National Fire Protection Association, NFPA. You can also access the NEC online through the NFPA website if you have a subscription. There are many resources available to help you understand the NEC, including books, articles, and online courses. Understanding the NEC is essential for anyone who works with electricity. It helps to ensure that electrical installations are safe and comply with the law. The grounding of electrical systems is a critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and de-energize the circuit. The NEC requires that all electrical systems be grounded. There are different types of grounding systems, including equipment grounding and system grounding. Equipment grounding connects the metal parts of electrical equipment to ground. This helps to protect people from electric shock. System grounding connects the neutral conductor of an electrical system to ground. This helps to stabilize the voltage and prevent overvoltages. The size of the grounding conductor is determined by the size of the overcurrent protection device. The grounding conductor must be large enough to safely carry the fault current. Grounding electrodes are used to connect the grounding conductor to the earth. There are different types of grounding electrodes, including ground rods, ground plates, and metal underground water pipes. The NEC specifies the requirements for grounding electrodes. Bonding is the process of connecting metal parts of electrical equipment together to create a low impedance path for fault current. Bonding helps to prevent voltage differences between metal parts, which can cause electric shock. The NEC requires that all metal parts of electrical equipment be bonded together. There are different methods of bonding, including using bonding jumpers and bonding bushings. Bonding jumpers are used to connect metal parts that are not directly connected together. Bonding bushings are used to connect metal conduit to metal enclosures. Overcurrent protection devices are used to protect electrical circuits from overloads and short circuits. Overloads occur when a circuit is carrying more current than it is designed to carry. Short circuits occur when there is a low resistance path between two conductors. Overcurrent protection devices include circuit breakers and fuses. Circuit breakers are resettable devices that trip when the current exceeds a certain level. Fuses are one-time devices that melt when the current exceeds a certain level. The size of the overcurrent protection device is determined by the ampacity of the conductor. The ampacity of a conductor is the amount of current that it can safely carry. The NEC specifies the ampacity of different types of conductors. Arc fault circuit interrupters of size are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. The NEC requires that the size be installed in certain circuits, such as bedroom circuits. Ground fault circuit interrupters, GFCIs, are a type of circuit breaker that is designed to protect against ground faults. Ground faults occur when current leaks to ground. The NEC requires that GFCIs be installed in certain locations, such as bathrooms and kitchens. Surge protective devices, SPDs, are used to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage electrical equipment. The NEC recommends that SPD be installed in all electrical systems. Wiring methods refer to the way that electrical conductors are installed. There are different types of wiring methods, including conduit, cable, and open wiring. Conduit is a metal or plastic pipe that is used to protect electrical conductors. Cable is a factory assembly of 2 or more conductors. Open wiring is a wiring method in which the conductors are not enclosed in a conduit or cable. The NEC specifies the requirements for different types of wiring methods. Boxes and enclosures are used to protect electrical connections and devices. There are different types of boxes and enclosures, including junction boxes, outlet boxes, and pull boxes. The NEC specifies the requirements for different types of boxes and enclosures. Conductors are the wires that carry electricity. There are different types of conductors, including copper conductors and aluminum conductors. The NEC specifies the requirements for different types of conductors. The ampacity of a conductor depends on its size, type, and insulation. The NEC provides tables that list the ampacity of different types of conductors. Terminations are the points where conductors are connected to electrical devices. There are different types of terminations, including screw terminals, wire connectors, and solderless connectors. The NEC specifies the requirements for different types of terminations. Labeling is the process of identifying electrical equipment and conductors. The NEC requires that all electrical equipment and conductors be labeled. Labeling helps to ensure that electrical equipment is properly installed and maintained. Electrical safety is the most important consideration when working with electricity. Always follow the NEC and other applicable safety codes. If you are not qualified to work with electricity, hire a qualified electrician. Before working on any electrical circuit, always turn off the power at the circuit breaker. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, including safety glasses and gloves. Never work on electrical equipment in wet or damp conditions. Inspect electrical cords and equipment for damage before use. Replace any damaged cords or equipment. Do not overload electrical circuits. Use extension cords sparingly. Do not run extension cords under rugs or furniture. Do not tamper with electrical equipment. If you are not sure how to do something, ask a qualified electrician. Teach children about electrical safety. Keep electrical equipment out of the reach of children. The NEC is constantly evolving to keep pace with new technologies and safety concerns. Staying up to date with the latest edition of the NEC is essential for anyone who works with electricity. Continuing education courses are available to help electricians and other electrical professionals stay up to date with the NEC. Many online resources are available to help you learn about the NEC. These resources can provide valuable information and insights into the code. Understanding the NEC is a continuous process. The more you learn about the code, the better equipped you will be to work safely with electricity. Always prioritize safety when working with electricity. By following the NEC and other applicable safety codes, you can help to prevent electrical accidents and injuries. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always respect electricity and take the necessary precautions to protect yourself and others. The information provided here is for general guidance only. It is not a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for specific electrical installations or repairs. In conclusion, understanding the NEC requirements for riser cables, service entrances, and the responsibilities of inspectors and utility companies is crucial for ensuring safe and compliant electrical installations. By adhering to these guidelines and seeking professional expertise when needed, you can contribute to a safer electrical environment.